All right, I'll restart from the beginning. Hi, everybody. I am Micah Hoffman, and this is my first time on the internet. Yes, it is. I wanted to welcome you and thank you very much for having me hit Lariat. I'm thrilled to be back here virtually. And this presentation is really cool in a virtual setting because unlike some of the other presentations that I've done where I've had to make the fonts really big and all because some of the rooms are really deep, this one I can make the fonts really, really tiny so you can get really up close to your screen to see the content. A little bit about me. Some of you might remember me from SANS Institute. I wrote and teach the Sec 47 open source intelligence class. Also, I'm the president of the OSINT Curious nonprofit. You might have seen our webcasts, podcasts, or other blog posts that are out there. I also have been in cybersecurity for, gosh, near 20 years now. Yeah. And the last five or so, I've been in open source intelligence. I also go by Web Breacher online, and I have my own OSINT Curious. I have my own OSINT-based InfoSec company called Spotlight InfoSec, where we do OSINT consulting. So let's talk about GitHub. Now, some of you already know about GitHub. It's that wonderful place where you go to download other people's free software or videos or PDFs or other stuff. That's really neat. For our purposes, for OSINT purposes, we might use it to look at people's bios. You know, some of the other talks that I was listening to today have been just amazing. Some of them were talking about how when you find somebody's profile, you're going to scrape the information about who they are, their username, information like their bio, their avatar for future use. And yeah, with GitHub, we have all of those things. GitHub is also a platform that allows a lot of different people to create user accounts, including automated accounts. And so we could also use GitHub to find accounts that are using, sending spam out or that are promoting sex sites or other things. We also can use GitHub to find sensitive data about companies or internal data, API keys, and those things that are being pushed to repositories in employees' profiles. Right now, we're going to focus on the left-hand side here. We're going to focus on people and bots. Now, if you're like me, I've always wondered about those amazing types of graphs and plots that people make when they're investigating like propaganda networks on the internet. You see these tweets go out and like Ben Strick or Conspirator Under Tango has these amazing plots of 30,000 Twitter accounts that tweeted this out at the same time. And I've always wanted to do something like that. Well, that's this project. Now, the thing you got to know about APIs, if you've heard any of my other talks, including the one that I gave last year at Layer 8, APIs are application programming interfaces. They're the way that our smart devices connect to many web services. So when you're doing Facebook on your mobile device, it's not visiting the facebook.com interface and pulling down all that human readable stuff, that human interface. No, it has a special backend that it's reaching out to. It it posts and receives information using a format called JSON. And we're going to see that later in the presentation. Now, the cool thing about APIs is that we don't have to do illegal things. We don't have to scrape all this stuff to gain access to the data. We merely ask for it and say, hey, here's my authenticated key, or sometimes we can use APIs without authentication. We can say, hey, I want access to that information. And the site many times will just give it to us. This is really neat. And for our purposes, if we're doing anything long-term with a lot of records or something over time, using an API is going to probably be much more efficient for your investigations. What can you do with APIs? Well, what if you wanted to look at all of the users on GitHub that have identified themselves as currently working for Microsoft and have currently identified themselves in certain locations? Well, you could make a request via the API, pull that data, and throw it into a visualization tool, like in this case, Maltego's case file. And that's what all of these little circles are. The red dots in the center are the actual locations. As you can see on the right-hand picture, this location is the Netherlands. And these user accounts have identified themselves as being connected to Microsoft and the Netherlands. I thought, that's really neat. But what about those bots? What about that spammy stuff? And I started looking, and sure enough, there's a whole bunch of accounts that were created on the exact same day, or even at the exact same second, or sequentially. And I started looking at that, and sure enough, we can plot these bots and how they're connected, and possibly discover people that are using software to create massive amounts of accounts on GitHub to promote a website or a Bitcoin exchange or something else like that. It's like, this is really powerful. So what I did was I used the GitHub interface, the actual API, signed up with an account, used the API to make requests back and forth. Now, you're probably thinking, oh, I need to learn Python for this. No, you don't have to. Many APIs you can use just via a web browser. You bet you got one of those. Yeah, the documentation for the GitHub API is at the bottom of the screen there, and you can read it and see that, hey, to get this information, you need to submit that data to this place. I thought, all right, well, let's try it out. So I did some experimentation. And from my web browser, I went ahead and started looking at what data would come back. And I was like, wait a second, when I make a request, GitHub gives me a user ID. In this case, it's where the number 2 is. This is ID number 1. This is the first user on GitHub, person named Mojambo. I thought, wow, one of the big things that we do in OSINT is we do username resolution. So if I can say, hey, give me record number 1, and you get Mojambo, and then give me record number 2, give me record number 3, and I do that for all of GitHub, what could happen? So I decided to go ahead and see if I could retrieve, legitimately using their API, all of the records for every profile in GitHub. And in 2019, I spent 3 months and a whole bunch of cloud server CPU time and network time making authenticated requests and collecting profile information from GitHub. I pulled 1 million records, 5,000 requests at a time. It took a long time. You might be wondering how I did this. Well, see, the GitHub API allows you to make a request like this. In fact, you could open up a browser and paste this URL right into it, and guess what? You're going to get results coming back. You don't even have to authenticate. Now, in this case, what we're doing is we're saying, I want you to start at user 0, and I want you to give me 10 records from 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And what you'll find is this JSON formatted content. Do this in Firefox if you're going to do it, and not in Chrome, because Firefox has a native JSON decoder that makes it look really nice and easy to read. But it's that simple. Now, some of you probably are being like, all right, I see the 10 there, Micah. Could I change that to 100? Well, try it out. This is being curious. This is experimenting with the data. I'll give you the long and the short. Yeah, you absolutely can increase that. And so what I did was I said, hey, start at record 0, give me 100. Now do that again and start at record 100 and give me 100 more, and so on and so on. And each time what I would scrape out is the login and ID. That's all, just login ID, and I made it a CSV. Because at that point, I didn't really know how I was actually going to do any of this. I just knew I needed to grab this data. Because see, the second thing we can do is once we have a profile ID, like in this case, PJ Hyatt, we can put that in a different API call, and we can retrieve profile information. Now, the first thing you're going to see is, well, in this section here, we have some gaps. Yeah, there's a lot more in the JSON that comes back than I could fit on the slide here, so I cut it out. But if you make that call, authenticated or not, you'll get information about this user. Now, this is interesting maybe, but maybe it's not. But when you do it in bulk, and you take every single one of the 39 million users that were in GitHub in 2019, and you do this, you get a really interesting result. Because see, in this content here, we have information like the ID and the username. Cool. We also have, are they a GitHub user admin? Interesting. Name, company, blog, location. Ooh, look at that location. It's null. Hold on to that. We also have other information about what they're doing, and we have the created at and updated dates. This information does not necessarily show up in their main human readable profile that you would go to. So if you just went to github.com/PJ Hyatt, it might say that they've been a user since 2008, but you may not see the exact time date there in UTC format. So what I did was I made a whole bunch of requests. For every login in all of these logins, make request for pull their profile data and then record it. And one thing you also need to know is that when you're doing this, the human readable format API, so if you just went to api.github.com in your web browser and you went to it via a Python script or some other script, there's some differences. And if you're authenticated versus not authenticated. Here's the example. Over here we have Chris Van Pelt's account. Now, I'm not doxing these people. All of this information is out there on GitHub. You could go to Chris Van Pelt's profile and you would find his name is Chris Van Pelt and crowdflower.com is the company that he says he worked for. This is not doxing here. Here we have an email of null. But if you make an authenticated API call, you now get that email address. Now, I'm not going to show you the email address, but you get them. If the user has not set their email address to private, and I'll show you how to do that at the end of the talk. This is a very busy slide, but I wanted to show you what that CSV looks like, where you have the ID, you have the name of the person, like the Mojambo, there where the number 2 is, and then as we go across the row, we get the type of account it is, whether it's a user or an organization, we have whether they're that GitHub user admin, their name that they've called themselves, the company that they say they work at, blog, location, email, etc. And you can see all of these different things, like here we have the IDs, 3s, here we have an email address, the company name, we have a URL. This is really interesting stuff to get, and it's free, and it's accessible. So I did this across 3 months, and I got 39 million records. Question is, how do you analyze 39 million records? I have no experience, and in fact, I was listening to somebody talk earlier in the conference, and I forget who it was one of the Track 1 speakers, and she said, I'm not really good at analyzing huge data sets, and I'm not really good with scripting. I'm like, I'm not either, and I'm doing a talk at 2 o'clock. So I did ask a lot of people that are much smarter than me, how do I analyze 39 million records to do interesting things? And I heard things like use Splunk or Elastic or BigQuery, and then I came across a friend of mine, and he said, let's use Python, Pandas, and Matplot. And see, the easy thing about this platform is that the Pandas program uses data frames that are kind of like Excel spreadsheets. And I just want to give a shout out real quick to Chalmer Lowe, who's my collaborator, helped me out a lot with the data analysis and some of the data here in the talk. So my platform for analyzing this looked very kind of isolated. I had a local VM, I had a MySQL database on that, didn't use cloud, didn't do anything, used PHP MyAdmin to manipulate the database, used Jupyter, Python, Pandas, and what you get with the Jupyter Lab notebooks is you get something that looks like what you see on the right, where you can take notes in a page, you can run code in the page, and it's really, really cool. So here I finally had a way for me to take my notes and do some exploratory data analysis. Let's talk about that data. this is what a data frame in Pandas looked like for me. Now, I'm really glad that I'm presenting here. I'm hoping that y'all can see all of that. If not, let me go ahead and blow it up just a little bit and take the left-hand side, and then we'll take the right-hand side just a little bit bigger here. These are the actual columns that we have, and you see we have ID, the login, this is their GitHub user name, we have their name, we have blog, location, you get that. But you also see that we have some artifacts because, let's face it, when I did my API calls, I stored this data in places where I wasn't keeping the original format. So anything that's not a true ASCII format, I think I might have gotten corrupted data on. So it's not perfect, but it's something. Now, when we move up, well, before I move over there, let me just show you this. You see the location column here? We've got people saying that they live in Buffalo, NY. We also have people that say they live in New York City or Montreal, Quebec, Canada. It's like, well, we've got a lot of different types of input that users can put in there because they're not constrained. And so one of the things that I had to do, along with Chalmers, is do some data normalization and try to make this as close as possible to other records so that we could analyze the data. On the second half of that data frame, we have email column for some users that haven't protected their accounts. We have the bio, and again, this is an anything goes field, so we'll see some really interesting things in the bio. Created at and updated. So here, the created at is the date when the account was created, date and timestamp in UTC time when the account was created, and the updated is just that, when it was last modified. So we had some accounts here that are pretty old. This one right here was created in 2018, and it was last updated in 2019, so they're still using it for something. So before we get any further, I just wanted to let you know that some of you are probably thinking, hey, did he report this stuff to GitHub? And the answer is no. But I don't feel like I needed to bring them into the picture, because every single spam account I found, every bot account I found, when I looked up their profile, it already said that their account had been disabled or suspended. So props to GitHub security for doing an amazing job with probably using many of these same techniques on their side, analyzing when accounts are created and what they're putting in different things to keep the number of GitHub accounts that are spammy or are bots down to a minimum. Also, before you ask, I'm not going to be giving my database to anybody. I'm not going to be giving my code to anybody. Just want to throw that out there. So from an OSINT perspective, what would you do if you had the access to all of these records? Well, obviously we can harvest emails. We can look at whose work says that they work for what companies. We can look at the locations that people say that they're from and combine that with other things like what companies they work for. Heck, we can even look for hate groups. If you know that there's certain words or terms that people that are promoting hate and violence against other people use in their bios, in their usernames, in their blogs, we can search through this for that. And then there's the bots and spam accounts, which I was like, I finally get to analyze things with bots. And then from a cybersecurity side, I started thinking as a web app hacker, because that's like some of the things that I did in my past. And I started thinking that, well, what if somebody ran automated tools against GitHub, like in a bug bounty program, and accidentally created accounts? Could we find that? Or what if people actually tried to submit, cross-site scripting or types of attacks, or we're putting in malicious URLs that are those short bit.ly links or owly links? Could we find that? The answer is absolutely. Stick around. And then I also wanted to look for the extra things that I really didn't even know what they were or how to explain it, and to analyze also the created at and updated timestamps. Now, starting with the easy things, yeah, I mean, if you have a database or an Excel spreadsheet with name and company, and blog, email address, it's trivial to search through that for any number of things. For instance, on the left, the 8,000 of the 39 million records, 8,461 records or rows. identified themselves as working or living or something with Berlin in the location field. All right, this is kind of social media, so do we trust it? Do we not? Does it matter? Maybe not by itself, but when we combine that with other factors like the company and all, that can maybe make a difference. Now, what about people who say that they work for the government in some form or fashion? That's what we have on the right there. 224 rows had the word government in the company. And you can see it's everything from New Zealand government to I think we even have New York State government. We have other governments, as we'll see here. This is visible government. That's not even a real company. That's a URL or a website. So sometimes the analysis is not perfect. What about fun things like logins with the word Micah in them? Yeah, none of those are my accounts, but I was really happy that there's other Micahs out there. Or an analysis of emails. Does the letters GOV appear in an email? And this is not just .gov. This is, here's va.gov, but if you look over here, we have Zambia, Ministry of Health. We have other ones that appear in here too. We've got 3,400 of those. Now, I could continue on doing these things and all, but I think you'd get kind of bored doing that. And yes, could we change .gov or gov to something like mail.ru or Gmail? Absolutely. Just it's whoever identified themselves and hasn't protected their account. We have access to that data. But in talking with Chalmer about doing really like data analysis, data sciencey things, we started to look at these value counts. And what Chalmer did was he actually took those creation dates and he chopped them up and said, all right, let's take off the year and count up how many records are from what years. And that's what we see in the left-hand section here. Now keep in mind, all of these numbers are times 1 million. And same thing over here. So we have over 9 million accounts here that were created in 2017 in the data set that I have. Now, I did this in the early part of 2019, so I don't really have 2019 or 2020 data. And, you know, this kind of makes sense. Over here on the right-hand side, Chalmer did the evaluation of the day that the accounts were created and found that, hey, it looks like 1.6 million. Is that right? No, it'll be 16 million. Oh, I'm bad with math. I hate that. A large number of accounts were created on the first day of the month. So January 1st, February 1st, March 1st, etc. That's when a lot of the accounts are created. It's like, wow, that's kind of interesting that analyzing these value counts gives us some interesting bits of data. So I started looking at other fields using the same technique, started counting up the number of times certain words or whatever happened in a field. And wouldn't you know it, if we look at the location field, the #1 location that's reported in GitHub user accounts is New York. And I thought, wow, there are over 160,000 accounts from New York. I would think that San Francisco or some other place that's more of a high-tech place would have a lot of accounts. And the reality is that this difference of why there's so many accounts that identify New York, it's not because they're real accounts. No, there are tools out there that when they create a bot account or spammy account on GitHub, they just fill in the location as New York, New York, New York. So we have hundreds of, or thousands in this case, of accounts with that. But we do see other locations here. And just so you know, I normalized the data by making it all lowercase and taking the first portion. So if it said Los Angeles, California, I just took the city name. Sometimes it works, sometimes it didn't. When we look at company names, we start seeing some of those spammy bot things, because I would have thought like, yeah, Microsoft, Google, IBM, tech companies would have a lot of accounts, and sure enough, they do. I mean, we see Microsoft has almost 15,000 accounts in the data set that I have. Google has over 5,000, and this company you might not have heard of called Click Here has over 25,000 accounts. I was like, that doesn't seem right. And you might have also seen these click above and click below to enter. those are not legit sites. And I was like, cool, let's go ahead and analyze this. Let's take a look at this and see what we get. If we just search for companies with the name dash, 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 click here, dash, dash, dash. Sure enough, we find some very, well, bot-like activity. We see blogs that are all pointing to a single domain, different pages sometimes. We see the creation dates here. All of these accounts were created on the exact same date and very close to other ones. And if you look at updated, look at this. These were all updated at the exact same second on the exact same date. Looks like an automated tool to me. Now, some of you that maybe do blue team or some kind of log analysis, you might also look at the logins and see that those are all English characters, A to Z, lowercase. Now, the reality is that some of those could be uppercase, but I've also lowercase this column to make it easier to identify. But that could also be a pattern for figuring out, is this a bot account or not? So I exported all of those records, all of the ones that had the dash, 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 click me or click here, and those carets with click above, click below, and I threw them into the free visualization tool, Maltego's case file. Now you could use Gephi, you could use some of the other tools that are out there for doing visualization. I just threw it in this CSV into case file and said, show me what you see. And what we see is the name of the company, that's those dots in the middle, and then we see the accounts around them. It's like, wow, that's really neat to see. So let me show you if you drill down on one of them. This is for the click link below. And here we can see that the click link below company string has actually a whole bunch of user accounts that are tied to it. And those user accounts, like the 187 accounts here, all are pointing at this exact same URL in the blog. And these 1,600 users all point to this URL. Wow, it was a lot easier than I thought to identify an anomaly and then do some visualization to pull out similar types of records and see kinda how we can identify what a bot account might look like. And this goes on and on and on. We can do that over and over and over again. In fact, when we move over to like the repeated emails, doing those value counts on the email column, what we find is that there's some emails that are found repeatedly in different records in GitHub. Here we have the number down here. We see the ICO stats or ICO stats at gmail.com account. It has over 100 GitHub records that have that exact email. So let's take a look at it. And when we pull that up, we see it's kind of spam. They're promoting their Bitcoin and Ethereum and Monero kind of cryptocurrency exchange. It's the ICO web. I'm not saying you should go there. I'm just saying this is the data that I saw in GitHub. We see the logins, the names, and if we remove the 1, 2, 3 columns that have similar information, what we can see now is, again, the information about how fast these accounts were created, and look at these sequential second type of updates. This is absolutely the sign of somebody using a tool or typing really, really fast to do it. Or maybe they have a whole bunch of interns that are creating these accounts. I was like, wow, that's pretty cool. And when we start to do things like check out, are these accounts alive? As I mentioned earlier, it was really, really simple to write a Python, 3 or 4 lines that said, take the login, go to github.com/that login name, and see if it returns a 404 not found page, or whether it returns a 200 page that, yes, there's an account there. Every single one of these accounts already disabled or dead. The accounts are no longer on GitHub. And what that means is that historical data can be found within API calls that cannot necessarily be found in the human web interface. So if I was, or you are, to go to Bitcoin exchanges with 2 S's on GitHub right now, you're going to get a 404 not found. Yet historically, that data exists within the API. Interesting point. Now, some of you are pen testers. Maybe you're doing the CTF. Maybe you did a bug bounty in your time. Anybody know who Peter Winter is? Yeah. Some of you know, you're nodding your heads, I bet. Yeah, Peter Winter from Winter Consulting at that email address is the default strings that are submitted into web forms when you run the Burp Suite Pro scanner across some website to find web vulnerabilities. Back when I used to teach the Sec 542 web hacking class for SANS and do web pen testing, we used to use this tool all the time. And now what we're seeing here is accounts in GitHub that have the name Peter Winter and the company and the blog and the location and email that show that perhaps somebody created those accounts using Burp Suite Pro. And for those of you wondering, can you insert cross-site scripting content into GitHub records? The answer is you can try, but it won't render because GitHub doesn't play that. So here, these records use that old cross-site scripting payload alert with parentheses. And what this would do is, if GitHub was vulnerable to cross-site scripting cyber attack, then in people's profiles or in other places where this data was pulled up, an alert box would pop up on somebody's screen saying true, or saying welcome, or DOM XSS, or whatever. So we have evidence that people have tried and failed to do cyber attacks. I didn't check whether these accounts are alive, but I'm pretty sure that they probably are not. But some of them are legit sites, like this one. You know, it's some developer and they're trying to do stuff. Now, within the data itself, there were some anomalous things that I didn't have time, and Chalmer didn't have time to explain, to investigate further. And then there were some fun things. Let's take a look at some of those. Now, we've already seen the data counts, the value counts for the data for some of the other comps, for email, for company. Well, it turns out that if we look at the created at timestamp and we say, for every second that an account was created, count the number of records that have that exact second and show it to me, we've got over 400 accounts that were created at the exact moment of March 11th, 2018 at 0600 UTC. At that exact second, that seems anomalous. And yet, if you start looking at the data, we get another interesting pattern. And I didn't look into this, but I was intrigued, because if you look at the top sites here, we see 2012, 2013, 2014, 15, 16, 17, 18, March 8th, 9th, 10th, 11th, 12th, and 13th at 6 o'clock. So every year on one of these days at 6 o'clock in the morning UTC, a whole bunch of accounts are created on the site. Interesting. Now, a next step might be to investigate how or why are those accounts alive, what tool created them. I thought that was kind of interesting. And if we take that, instead of looking per second and look at per day, what we do is we find some other days are more important to us. For instance, we have over 300,000 accounts that were created on September 1st, 2016 or September 2nd, 2016. And to November 26, 2016, there were a whole bunch of other accounts created. And this is really anomalous. As we look at the kind of the tail of this graph, we just get smaller and smaller numbers. These really stick out that on those dates, something happened. Some people created a whole bunch of accounts. Why? What they are? I didn't look into, but you can. Now, if we look at updated timestamps, instead of just the created ones, we find more anomalies. For instance, again, we have 2019, March 10th at 6 o'clock in the morning. We see there's a huge number of accounts relative to the other ones that were created and that were updated just on that, at that very second they were updated. Wow, that is really interesting. When you look at updated per day, what you get is something even more interesting. Now we're seeing different dates, 227 and 228, which lead up to March, right? But here, 227 and 228, this is times 1 million. We have 3 million updates that happened on those dates. Interesting. Why? Somebody's using some kind of automation. There's some other anomalies which are not so great. Yeah, frowny face here. Some people have accidentally or purposefully, I don't know, put private keys, private PKI keys. These are encryption keys. Private keys are the ones you don't share, and yet some of these accounts have them in their blog, location, or bio fields. Just a handful, but they're out there. These are people that have either misconfigured their accounts or have thought that that's a good idea, or maybe it's some software that puts it in there. I don't know, but that was a little bit disconcerting to find. Lastly, does anybody know what this is? There's actually two different things in this slide. Some of you might have noticed these slashes, dashes and all, and started like saying, oh, those are dots and dashes. Hey, dots and dashes, could that be Morse code in people's bios? And what about this other stuff with the pluses and all? Does anybody know what that is? Well, I did. Actually, the last part, the second one, the brainfuck stuff, that Chalmers came up. That's the type of encoding. That's what it's called. I'm sorry for using a bad word. That's the name of it. The first part, the dots and the dashes, that's Morse code. Yeah, people put dots and dashes in their bios. And what I've done is I've used CyberChef to go ahead and translate those dots and dashes into whatever the person has put in there, like this little emoji, yay. And then for the brainfuck stuff, we have strings like, I will code for food, I like bacon. Kind of interesting. I love finding, I look at this and like, you know, I think, wow, somebody knew that one day I was going to look at these records and find this. I also found ASCII art, which didn't look really good when I showed it on the screen here, and other stuff in people's bios. So thank you if you're one of these people that put this in your account. Thank you so much for sharing that information. It made me chuckle. So that's nice and all. What could we do next? Well, the first thing is, again, my goal was not to weaponize this database. I'm not doing anything more with it. It was an interesting way for me to investigate and to try out some new things, to learn new stuff. For many years, I've said, well, I'm not a data scientist, and this data set and the interesting things that it showed me that I could gather through APIs, it allowed me to have a reason to learn how to use APIs and how to process large data sets and how to analyze it. Now, of course, one of the next things that we could do is do that second part. I showed you a slide where it showed one thing that we could do and they had this big X on the other side, so we're not looking in the repositories. Well, it would be really neat to look at all of those spam accounts, all of those click here's, other ones, and see what repositories, what data they're actually storing and sharing on GitHub. Did they also create Git Pages accounts and they threw up some kind of static website? I don't know. I didn't have time to take a look at it, but we could take a look on that. Also, you know, thinking about how other people might use this data or these techniques, because all of this was free. It wasn't, I mean, it does require some technical chops to do it and people like Chalmers that are smarter than me to help you out, but it's reasonable to suspect that other people might have been mining GitHub data for years and years and years. This data goes back, you know, a long ways. So the question is could you do some kind of data pull like this on a monthly basis, on a quarterly basis, and watch for a given account when they update their email, when they update their company that they're working for, and track users over time? The answer is most definitely yes. Also, recruiters, sourcers, if you're out there, yeah, we have emails, usernames, companies, sometimes we even have positions. This data is rich within. And so I kind of want to just throw this out there that, you know, a lot of the stuff that's in this data set, whether you get 39 million records or you start pulling just smaller data sets, a lot of this information is really interesting to analyze. I mean, this is one of those OSINT curious type of itches that I have. And I start thinking about all the all of the social injustice that's happening now in the world, and the other stuff, whether it's repression or inequities in just all parts of life. And I start thinking about people's names like mine, Micah Hoffman, who's on there. My name definitely sounds Jewish. Could somebody be grabbing my data or other people's data off of GitHub and doing things with that information? So one thing that I do suggest that you do, if you have a GitHub account or your sock puppets have GitHub accounts, is go into this place in your profiles and keep my email private. Check that box. Check the box that says block command line pushes that expose my email, because there's other stuff we can do in GitHub. There's the Zen scraper, which will scrape out emails from commits that are made to the site. And if you don't know what that is, look up ZEN and GitHub. Really nice tool. But if you want to prevent your information from leaking, go ahead and click on these. It takes a second and it'll really increase your overall perspective. And I'd just like to leave you with the words of MTIM, Kovich, readers, and the others here. Hack the planet, everybody. Hack the planet. Thank you very much. Here are links to a bunch of the sites that I care about. My email if you have a question. Also, I will stick around and answer questions from Discord, and I will be in the chat. So, are there questions for me? And I don't have Discord up, so if the moderator could read and find any questions? If not,
yeah, no, it's been quite an interesting chat, Micah. What's been great is a lot of people have been kind of bringing up just some of the interesting pieces you found. And are there any intentions on your part for sharing some of your source code details, or at least better understanding some of the details behind how you're able to identify what you did?
My gut says no. The two URLs that I shared in the beginning of the talk, for that pull the login and the ID, and then the second one that pulls the actual profile using the login name, those are the most helpful. And honestly, if you just use those two and make a for loop using curl, and on OSINT Curious website, we have 10-minute tips on how to use curl. Or if you use a little 4-line Python thing, you can you can use the API with GitHub as well. And so I do not intend to share these, the data frames, the database, or anything like that, or put all of this in GitHub. I know that some of you are like, could you throw it in GitHub? No, absolutely not. It's cannibalistic.
Especially after what you've been highlighting.
Yeah. But you know, to GitHub's security, to their credit, they've done an amazing job. Every time I looked at, hey, I bet this is live. Nope, the accounts were shut down. So it's good stuff.
And just another question coming from the Discord chat, just in consideration regarding some of the preteen stuff you had highlighted, how did you end up reporting that to GitHub, or what was your approach there?
So regarding the what? I'm sorry?
There's a mention just in terms of reporting things to GitHub, in terms of things you found. So if you were scraping anything that was either inappropriate or even, let's say, things that would be of questionable in nature, is that something that's come up in your OSINT research?
So the answer is yes. There were things that were questionable. I did not look for CSAM, child sexual abuse material, or links to it, although I think some of those IOP.com URLs did point to preteen this and that. All of those accounts had already been disabled. So me reporting them to GitHub saying that in your database of user accounts via the API, I can still pull this, but it's not publicly presentable. I didn't feel like that was necessary because they obviously did know about those. aside from that kind of stuff, I didn't really find anything that I felt that I needed to report to GitHub. But if I look into the data further and find things that are still alive and publicly accessible using the human interface, then I would definitely report that to GitHub security.
So I guess there's a related question where just in terms of some of the data you're finding, linking with other social media platforms as a part of your OSINT work, have you found this to be a pivot point for you in terms of you may find something in GitHub and let that lead into continuing investigations, or just what are your thoughts and approaches there?
Yeah, whoever said that is thinking like, no, it's an investigator, right? So one of the things we always try to do is tie a name with a login name or a username and an email address. That's like the golden rule. So for many years, people have collected breach data, which had that information, and you could use that as kind of a dictionary to say, oh, reader Z, they use this email and they say that they work for this company, and then you can pivot. For this, I haven't used this in OSINT investigations, but it would be something that would be really useful if you do have somebody that has created an account. If you use the What's My Name app, or you use Sherlock, or you use one of the other wonderful user enumeration tools to find an account, then look them up in this local, or heck, just make a quick API call. You could make a quick API call to GitHub using one of the URLs I showed earlier and say, do you have this login? And if you do, show me the other information. Now, it's not going to show you the email unless you hit that API using an authenticated user via Python or something like that. So you do have to take some extra steps. But absolutely, we could use this as that data dictionary of, I have this username, let's see what I already know about them.